Ravishankar? Hello? Can you hear me? Hello?
Hello.
Yeah. So it seems Ravishankar is getting some problem. एक minute. Let us check some alternative.
आपको
So your voice is not coming, Abhishankar. Please unmute yourself. Your voice is not coming, Abhishankar. Please unmute yourself.
So can you hear me now?
Yes, we can hear you.
Sir, I think we can't hear you, sir.
Yeah, we cannot hear you, Abhishankar. Again, it seems you have muted yourself. Yeah. Now I think it will go.
See, the moment I share it, it seems like it mute me.
Uh-huh.
Okay, let me again try sharing. Okay, can you hear me now?
Yeah, we can hear you, but still your screen is not visible. Now it is
Yes,
visible
sir.
and we can hear you also. No, we cannot hear you. Some issue today. हेलो
Uh,
हाँ अभी आ रही है आवाज
so I think I don't have to maximize this. We'll go through like this. Will it be fine?
okay
So now you can hear me and can see slide.
correct
Yes, sir.
Okay, very good. So today we are going to see artificial neural network. This is the important machine learning concept. Okay. So how many of you heard about deep learning? So artificial neural network is backbone of deep learning. So how many of you heard about deep learning? So this is also a machine learning technique, but somehow advanced than machine learning. So how many of you heard about deep learning? So no one have heard about deep learning.
No,
We
sir.
have heard the word.
So you have heard the word. Okay.
Yes.
So if you see deep learning, so deep learning concept start from artificial neural network. So backbone of deep learning is artificial neural network. Initially, they call artificial neural network, but the moment they have increased the computational power and all, and able to increase the number of hidden layers, they started calling artificial neural network as a deep learning. So this is the deep learning concept is not new. It's old actually, but now you can see that is more popular. That's why people are now doing more research on deep learning and artificial neural network. So artificial neural network is also a machine learning technique. You can also solve like what I taught you in random forest in KNN. By artificial neural network also you can solve both problem. You can solve classification problem. You can also solve regression problem. Okay, so both type of problem you can solve through artificial neural network. You can also solve multivariate problem where you have multiple output related with multiple input. So that is called multivariate problem where you have multiple inputs. So such problem also you can easily solve through artificial neural network. So artificial neural networks, so some scientists thought it can we mimic our brain. So so they thought can we mimic, they try to understand the brain or this brain function, and then they thought that can we replicate our brain through some model, and from there it started. So the way the brain function is, brain contains around 100 billions of neurons, and all these neurons communicate through electrochemical signals. So if you heard about, if you have learned something of biology during your not undergrad, I think 12th, you have, if you remember about the brain, how that it function, and I think in 12th we had something on how our brain works and that. So core element of the brain is neurons, and all neurons are, and in a brain there are 100 billions of neurons, and all neurons are connected through a junctions called synapses. You can see this. This is a single neuron. Okay, so there are, you can see there's something called dendritis. So dendritis, okay. Dendritis is something like, it is a receiver actually. It receives inputs. Okay. And in synapses, all neurons are connected through this. All neuron, there are 100 billions of neurons. This neuron, and they have some connection, and this connection we call a synapses. Okay. So why we are talking about all this? Because we want to, because scientists talk about this and try to replicate whatever they think about the brain through some mathematical model. Okay, and these are the important concepts of our human brain. And the core of our human brain is neurons, and how these neurons are connected to each other, how these neurons receive information from other neurons, and how this neuron passes information. So these are all important aspects of brain, and that only scientists try to model it through some mathematical equation. And this journey not started now or not 10 years before. It started late 1945 when one mathematician and another was neuropsychologist, that was called Madame McCullough, and mathematician was Walter Pitts. And these are the model they have generated or thought through when they first try to model our human brain. Okay, are you following or not? Because these are the important concepts, and then this only you can translate into deep learning and other stuff. Okay, so these are the first network they have created. So this, and they have demonstrated it through a electric circuit. So how it works is, they have n number of inputs, and all inputs are connected through a weight, and this weight will come through this node actually, and neuron. You can say that this is neuron or node. So neuron and nodes both are same. And what it's saying that if all this sum, weighted sum of input and weight greater than threshold, this output, they will get some sorts of output. So these are the simple network. You can just think that they have thought it in 1945, and from here only that artificial neural network research has started, and it's going on. So core of all this is what I told is neuron. So first we will see that what is neuron. So core of artificial neural network, or ANN, is neuron. So we'll go and see what is neuron and what are the different types of neurons. Okay. So there are three types of neurons. And neurons you can call as nodes also. Either you call this as a neuron or you can call this as a node. So today we are going to have theory only, so you have to just listen it. When we go and solve some sorts of example, you may enjoy this. But this is also good to know actually, because these are the core. And if you understand this, I think that will be good and it will help you to understand this better. And always you will get all this terminology. What is hidden layer? What is output node? What is input node? All this you can regularly see the moment you start learning deep learning or artificial neural network. So it is good. You just pay attention here. Okay, so there are three types of node, or you can say there are three types of neurons, and it is called an input node, hidden node, and output node. So what is use of input node is it receives the input information. So in deep learning, we have different types of input. So either input can be numeric or either input can be text. Input can also be image actually. Input can be audio or input also can be video. So there are plenty of input. You can use it through this artificial neural network, or input can be mix of all together. So if you are training some artificial neural network, so it may happen that some of these inputs are numeric, some of these inputs may have images actually. Okay, so all together you can process it through the artificial neural network. So that is the beauty of neural network. And another thing is, the moment you go with the artificial neural network, you don't have to be domain expertise actually. Your network will take care. Once you design your network, you just say that how many input layer, and so we'll see actually after this. So you don't need to much pre-process your data. So pre-processing is like the way we do it in other machine learning. We don't need that much of pre-processing. Your network, if you have able to create a good network, that will take care all of this. Okay, so we are in, so input layer, you receive your information and it processed through a mathematical function, and that mathematical function is called activation function actually. We'll see that also. And there is a hidden node. So after input layer, the next layer we call it hidden layer or hidden node. After the hidden node, it is called output node. Okay, so as I told you, neural network is not new. It started in 1945, and then after few years of research, the moment come when people stop doing research on neural network because of multiple reasons, and then again it started in 1989, if I'm not wrong, and then again it will go with some pace but not not with like full phase, because we were not able to show some application, real time application, that neural network helping to solve some real time problem actually. We are not able to help it, but there are research parallelly going on actually. But after 2009, if I'm not wrong, after AlphaGo or some more application, we were able to show that neural network can solve real-time problem. There is boom on neural network, and then something called deep learning has coined. And deep learning is nothing but the number of hidden layer actually. At that time also we have better, 2000, after 2009 we got some better algorithm to solve larger network problem. And then we also had that time that we are able to demonstrate neural network through some real solve some real time problem through neural network, and then it pick up momentum. And now if you can see, every company are now using neural network or deep learning stuff. everywhere you can heard about deep learning, either in terms of image processing, that is also part of deep learning, either image classification, caption generation, these are all part of image processing, or forecasting, time series forecasting actually. So these are all part of time series modeling. So for, let's say, forecasting of your stock price, these are all part of deep learning. And core of deep learning is neural network. So you just increase your number of hidden layers, people start calling it deep learning. So in 2009, they told that if number of hidden layer is more than 8, then it is something is deep neural network. Okay. So this is how this neural network is started, and now everywhere, every company are now utilizing neural network to solve some sorts of real-time problem. Okay. And
Can you explain once again hidden node?
okay, hidden node is it receive input from input layer. Okay.
Yes.
So basically, just think there is. I will just show you. Okay, I don't have network now. I think when we'll go to next slide or other slide, we'll have network. Then you can see what is the hidden layer and what is the output layer. But just
Okay.
to think it first, it will receive input from input node, and then it passes through the output node. Okay, so hidden node is some sorts of neuron, or it is bunch of neuron who receives input from the input layer or input node. Okay, because every time they collect information, they have to pass information once it cross some threshold actually. So first input node, it will pass it to hidden node, and then hidden node to output node. Will come and show you exactly how it look like. And output node is the last node, or you can say that node give you result, which receives input from the previous layer. That previous layer can be input layer. If they does not have hidden layer, that will be simple architecture of neural network. And if it is a hidden layer, then output receive information from hidden layer, and it will transfer through some sorts of mathematical function, and it will give you some sorts of result. So to understand this, how this actual how this neuron look. So this is the thing. This is how one neuron look. So this is the simplest network actually. You can see this network is something somehow looks similar to this first Macallan pit neuron. Okay, so this is also receiving input. There is one neuron, one node, and once it and sum of all input, if greater than some sorts of threshold, it will give you some binary, either 0 or 1. Okay, this was the simplest neuron, so we will understand it through the simplest network. And this network, they call it perceptron. I have not written it, just write it down. So this type of network, they call it perceptron. This is the single hidden or single layer network. You can just think about it.
Can you
Okay,
repeat the word?
perceptron.
Perceptron. Okay, sir.
Yeah. So single layer neuron. Just see this. This is very simple network actually. What it is doing? There are n number of inputs or n number of features, and all feature is associated with weight, and it is now coming to the neuron. Okay, see that right hand side top one. Okay, so what it doing, it is associated with all input, and it is now summation of wi xi. Correct. First step is it collect all information, weighted information of input, and sum it all. Correct? You have m input, I goes to 1 to m, wi xi. Okay. So basically, this the single node neuron collect information from input, and this is weighted information of input. So weighted sum of input. So is it passing it to output? No, this is not. Actually, beauty of this is it is not just weighted sum of this. This input transformed through some mathematical function, and that mathematical function we call it activation function, and that is the beauty of neural network. Just what they are doing, they are collecting all information here to the node, and at the node one mathematical function is sitting, that all input is passed through that non-linear or linear mathematical function, and that resultant passed to the that resultant is output. Understood or not? Because this is important concept, how that neuron works, and how the perceptron works.
Sir, which is the hidden node here?
So there is no hidden node, only one. You can say there is only one node actually. Okay, this is only one node which is connected with your input. That's all. So this is the simplest thing you can think about the neuron or neural network. This is the simplest architecture you can think about your neural network, and that is called perceptron. Okay, we'll show you how this hidden layer will look like. Okay, but now you just understand what is neuron. I will show you how this hidden layer will look like, and how this input transfer input, and then how the transformation goes from one layer to other layer, and it translated into output. Okay, now you have to understand this, how this neuron works. Okay, single node, that's why I took one single node neuron. This is only one neuron. You can see there are multiple neurons actually, all linked together. That is fully connected network. We'll see later. But in this, what you can see, there are n input, and all input have weight. You can ask actually, how do you assign weight? Can you think actually how do we assign weight here? How this weight are coming associated with all these input? Can you think? All this weight are,
Strong.
yeah.
How is the signal?
How the signal?
Yes, it's a weak or strong.
Okay. Yeah, correct. Actually, if that information or particular feature is important, and that strength, that weight is nothing but the strength of connection, you can just think about it. How this input are related with okay. So what it is doing? All input weight connected with the sum of all the wixi, and then this wixi will transform it through some function that is called activation function. It will transform your input, and that result to output actually, and that is the beauty of. So there are two beauty of neural network. One is hidden layer, another is activation function. So we'll now see what are the different types of activation function. So the activation function is something, a mathematical function, you just think about it, which transform your weighted sum of input, which is collected through the different sources or different nodes actually. You can also think activation function as a transfer function, because it transfer your input into output through some mathematical function. And there are, I just listed down these 5 different types of activation function, but if you can Google, there are plenty more actually. But these are the most important activation function used in artificial neural network. Okay, so we'll see one by one how this binary steps will look like, how this linear will look like, sigmoid, 10H, and ReLU will look like. Okay. So this threshold function actually, what it says that if Wxi, sum of this Wixi, so if x greater than equal to 0, then it will be 1, else it will be 0. So this is nothing but a step function actually. How this will transfer your Wixi. So y is nothing but your phi x. Y is your phi x and x is Wixi. So when this is greater than 0, it will fire, otherwise it will be 0. Okay, so if you have gone through some control book, you have seen this type of function. This is nothing but the step function actually. Okay, another mathematical function is sigmoid. So all these different activation functions sits on different nodes. Either it is in output node or it is in hidden layer. Okay, sigmoid function. So sigmoid function, if you remember, can you tell me where we have seen this type of function in our earlier class? Not now, it may be you have seen it in your first semester class. Can you?
Sir, logistic regression.
So logistic regression actually, when, so beauty of this is this output varies from 0 to 1, correct? Output. So let's say you are solving a classification problem, and if you want to have results in 0 to 1 probability, correct? And probability like from 0 to 1. So what you can do is you can use sigmoid function in your output layer. Okay, so whatever sum will come, it will transform and you will give always result in between 0 to 1. Correct? Can do it or not? Following it or not?
Yes,
Okay,
sir.
so every nodes will contain some sorts of, just think every node will have some sorts of place to hold this function actually, which is called activation function. This is a mathematical function which transform your input actually. So let's say you are solving a binary classification problem, you just keep this in output node and then input, whatever input it will get collected from previous layer, it will transform it through this sigmoid function and give you result from 0 to 1. That will be your probability. Okay. Other than this, there are few more, that is called rectifier. This is very important actually, rectifier. And I think this is the most used activation function now this day in hidden layer. So you have multiple choice actually to use different types of activation function in your either output layer or in input layer. Okay. So there is another rectifier. This is like a linear. You can see this is nothing but a linear. So when it is negative actually, this is 0, or below to less than 0, phi x is 0. The moment it is greater than 0, this have a linear y equal to x type of graph, and this is the most used, I think, thing. And there are lots of advantage and disadvantage which thing we have to use at where actually, like if you are solving a binary classification problem, you have to use what do you call it, sigmoid function. If you want your the thing has to be continuous, you can use rectifier actually. And there is another is something called tan h. This is how this look. It is symmetric about origin actually. You can see, and instead of varying from 0 to 1, it varies from -1 to 1. Okay, so there are two concepts we have learned today. One is node, another is activation function, which is sitting on node. Now we'll see actually all this. So let's say, how do neural network work actually? Now we'll see all hidden layer and we'll see all this. So how actually this neural network work? Let's say you are solving a problem where you have to predict house price or properties of price of that particular property based on some feature, like what is the area of properties, what is bedroom, how many bedroom it has, or how far it is from city, and what is the age of your properties. Correct? Just think this is the network actually. Just think this is a input layer and output layer. That's all we have. There is no layer actually. There is nothing, just input layer and output layer. So all input are connected to the output through some weight. Weight is from W1 to W4, which is associated with all these features. So price can return a W1x1 plus W2x2, like W3x3 and W4x4. Correct. Just simple network actually. So what we are solving it here actually? Can you tell me? So this is nothing but a linear regression problem actually. So this is a linear regression problem, correct? Where your output is linear combination of your input. So, but this is not the way we want to use neural network, because beauty of this network is hidden layer. And now we are going to see. So can you? So this is correct, na? Your price is linear combination of all this input associated, and all input are marked with the weight. Correct. Simple linear regression problem. So you can solve regression problem, simple linear regression problem through network also. But this is not the way we want to solve neural network problem. And beauty exists when you have multiple layers. So this is the how hidden layer look like. Can you see now how this hidden layer look like? So apart from input layer and output layer, there are another layer exists that is called hidden layer. So now all feature will go and connect with all these neurons, or you can say all these nodes, and all these nodes have some sorts of activation function. So activation function sits on this node, and after connecting all this together, this is how this network look like. So all this will connect with different node, and then weight will associated with each, and this weight will come from the training. When you train your network, then it will come out that which feature is important for which node. All this will come out through the training. So all weight are go and assigned to individual input. Okay, input, and then connection it through the node. So this is how the fully connected network looks like. So all inputs are connected with all node, and then so first it will go and get information here to the first From the input layer, information will transfer to a hidden layer, and from the hidden layer, information will transfer to the output. And all this will be transformed through some sorts of activation function, whatever we have seen it in previous slide. Are you following it or not? Because this is important.
Yes, sir.
Interesting, na?
Yes, sir.
There are input node, there are hidden node, and there output node. Okay, so people were solving the small problem actually. So because we don't have that much of advanced computational facilities, we don't have the advanced algorithm to solve all this problem. So people were solving one hidden layer problem, two hidden layer problem, and then people start calling same thing after eight hidden layer. They start calling this as a deep neural network. Okay. So deep neural network, if you heard somewhere, this is not new, but the one step ahead of neural network. You can just think about it, because same algorithm we are going to use, but there are a number of hidden layer or more. So if you have like 100 or 200 hidden layer, and it is all fully connected layer, and then if you have more data, it may happen that you require a month to train your network. Okay, and there all fast computing GPU will come to solve all this problem. So we have seen actually how do neural network work. Now we are going to see how do neural network learn actually. We are going to see one or two algorithm also. We are going to see gradient descent algorithm. And if time permit, I will also show you how the stochastic gradient algorithm work actually, how this training happen actually, how this back propagation, forward propagation, all this I will teach you. So this is going to be fundamental of your deep learning. So we'll see now how this neural network learn actually. So come with again simple network where you have input connected with a node, and this node is connected with, you can think this as a single layer network. So again this is perceptron actually. Okay, so this is connected with AIM input, and all AIM input connected to node with weight which is W1 to Wn, and it collect all this information Wi xi, transport it through activation function, some sorts of mathematical function, and will give you output y. But this is not. So how this happen is, first what it will do is, first it will go and assign weight randomly. Okay, so because you have to start algorithm. Okay, so so you have AIM input, it will go and assign weight, and then it will go and calculate what is the weighted sum of xi, and transfer it through activation function, and will give you output y hat. So y hat is your predicted output, correct? Then it will go and match with your actual output, and it will also calculate something cost function actually. Now let's say we are solving a regression problem, and this cost function you might have seen it in when we are solving least square problem. So basically idea is, cost function is nothing but minimizing the error between y hat and y, means your predicted values and actual outputs. So basically you want to minimize the deviation from the actual output, y minus y hat, and then we are taking a square to make it convex actually. Okay, so you have assigned weight here, You have calculated what is the weighted sum of input, transferred it to the activation function. You got one output, and then you have matched with output. You got a what is the error associated with it, and then what next we will do? Next, what we'll do, we'll pass this information. Boss, I got this error, this much error when you had this weight. And then what it will do, it will go and change the weight, because you have control over weight only. If you fix your activation function, you have only control over weight, which is decision variable, which you can go and tweak to minimize the output, and nothing else. You can't go and change input. No? You can only go and change weight, and then it will pass it through this, and then it will go and change this weight again. It will go and calculate output, and see that what is the error. Once it says that your error is below some threshold, it will come out, and that weight will go and assign to each and every input, and that will be your final network actually. So this, I just explain it through a simple network, but this is not so easy actually. That's why we are going to see some algorithm called gradient descent, how this actual training happens to this network. Okay, but this is the concept actually. You calculate every time you go and calculate error, you adjust weight, calculate error, and once you see that your objective function is not changing much, or it is below some threshold, you just come out, and that weight will go and assign to each and every unit input. So this is how this neural network works. So next class I am going to teach gradient descent, some algorithm actually that is called gradient descent, and that is important actually, important algorithm. I think in first semester whether you had chance to learn this algorithm gradient descent, because it is popular
Yes,
algorithm to solve in optimization problem. If you are formulating optimization problem and where you have to estimate theta, this is the most popular algorithm.
no, sir, we didn't.
So you have chance to see this, correct?
No, no, no.
No?
Yeah.
Okay, anyway, I will teach you. So another class is also going to be theoretical, not much practical actually. But if you are interested to solve some sorts of problem in deep learning, I will solve one problem in deep learning and show you exactly how this training happens. Are you interested to see this some problem in deep learning?
Yes, sir.
Then you do one thing, you install Keras in your system. So I will introduce another package. We can solve same thing through this what you call scikit-learn, but there is a package which is especially for deep learning actually. So if I introduce to that software, it may happen that you can explore more and then can solve other problem also in deep learning. Okay. Are you interested solving it through another what do you call package called Kira, or do you want it through scikit-learn only?
Oh, no, sir. We will install the new package also.
Yeah, you install something called Keras. Okay, so to solve deep learning problem, actually Google has developed software. If I don't remember, that is that called one is Theano and another is TensorFlow. Yeah, TensorFlow. Okay, Google has developed TensorFlow, and so TensorFlow had so many hyperparameters. Hyperparameters, you have seen it in random forest. There are 10 or 20 hyperparameters in random forest. Remember, you had lots of hyperparameters, and that model performance were depend upon these hyperparameters. Remember or not?
Yes, sir.
Okay, similar to this, in TensorFlow, which were developed by Google, had multiple hyperparameters, and people, it was not so handy for people to use it, and if you are expert only, then you can use it. Then these Kiras came out where they have fixed some of this hyperparameter, and then they have given, because they know that some of these are not influencing much the way others are influencing. So for other, for some of this they have fixed it, and this is very well documented and designed. Actually, lots of academias also they are using this package Kiras. Okay, so we'll also learn this. I will introduce this also. So then by the end of this course, at least you will have two package actually. So I will also give you choice actually. There after this neural network, one topic left. We'll have one topic left, that is the support vector regression. So what I understood from earlier syllabus, already you know what is support vector machine, correct? You have learned SBM.
Yes, sir.
Yes, sir.
Okay, so that is SBR is from same support vector machine that we are solving a regression problem. But if you are interested, I will teach you CNN actually, convolution neural network, image processing actually,
Okay, sir.
instead
That
of
will be
SBR model. Because anyway you have learned SBM, so if you learn these two, I think that will be fine. So you will have some knowledge of deep learning also. And I will give you one example actually. I will solve one example, and then that's all. So you just think through it, whether shall I teach you SBR model or convolutional neural network, CNN.
we will prefer CNN, sir.
Okay.
CNN.
Okay, so this will be more advanced then. So you will be more advanced than. But one thing is the why I took that SBR model. Lots of project actually I have used SBR model. See, these are the thing. Let's say you are doing some sorts of experiment actually, and deep learning only you can do when you have plenty of data or data is coming from sensor. But sometimes what happens is data is coming through experiment, and we don't have much experiment actually. So then we cannot use this type of algorithm where you need lots of data to train. But good to know this also. Anyway, you know what is the support vector machine. I will teach you CNN. So we will continue with deep learning. Okay. Okay.
Okay, sir.
Okay, sir.
Yes, sir.
Okay. Very good. So the one more thing actually, I have some meeting schedule on Thursday. So can you the people tell me, other than the Thursday, when shall I can take class?
You can Wednesdays. We can take Wednesdays one if you want.
So Wednesday I can take class, correct?
Yeah.
Yes, sir.
That's fine, because okay, let me just give me 1 minute actually. Let me check my calendar, because now they are putting in lots of meeting actually. So Thursday, this 7:30. So Wednesday, this Wednesday I don't have any meeting actually. So this I don't have meeting, so I will take class on Wednesday. Okay. See this, I have class on. I have meeting scheduled Thursday on 7:30. So I will take class on Wednesday. I will continue it from. this. If you people get some chance, you also try to learn all this concept because these are like very good, and these are advanced concepts. Okay, boss, we'll meet again on Wednesday. Bye.
Okay, bye.